Alright, so this video is going to look at multiplying and dividing rational expressions. We're going to do closure problem 3-130. Perform the indicated operation on each of the following rational expressions. Be sure to state any values of the excluded variable and that your final answer is simplified. If a graphing tool is available, check the graph of the original problem to see if it coincides with the graph of your answer. Okay. I see that part A is multiplication and part B is division. So with multiplying and dividing, my first step is always to write all the pieces, all parts of the rational expression in factored form. So let's begin by factoring part A. For x squared minus x minus 6, I'm going to do this one with a box and diamond, but over time I'm going to stop using that, just a heads up. So I'm going to draw my box and diamond. X squared is the first term, goes here. The last term, c, negative 6, goes here. And I multiply those for the top of the diamond, negative 6x squared. My middle term, negative x, goes in the bottom. So I need to think about what multiplies to get negative 6 and adds to get negative 1, because that's negative 1x. I know that 3 times 2 is 6, and if I want them to add to get negative 1, then I need to start with a negative 3x and a positive 2x to get negative 1x. I want to add it together and multiply to get negative 6. These two terms can now go in my box, and I can pull out greatest common factors. The top row is negative 3, the bottom row is x. The first column is x and the second column is 2, meaning that x minus 3 times x plus 2 are the factors for x squared minus x minus 6. X squared minus 9 in the denominator is actually the difference of squares. We learned this pattern that I can just add and subtract the square roots of each piece. So x squared square rooted is x and x. 9 square rooted is 3, and then 3. So one of them's going to be plus and one of them's going to be minus. That's the difference of squares. Okay? Now I'm going to multiply. Let's do box and diamond one more time, just in case we're still not positive how to factor. So I boxed x squared plus 5x plus 6. I'm going to draw my box and diamond, generic rectangle, area model, whatever you call it. X squared, first term, positive 6, so I have a positive 6x squared, and they need to add to get 5x. Okay, so 6 is the multiplier, 5 is the adder. I know 2 times 3 is 6, and 2 plus 3 is 5. So I'm going to have 2x and 3x. I'm going to fill that in, which pulls out a 2x, x, 3, leaving factors of x plus 2 times x plus 3. Okay? And then finally, this one's denominator. It says x squared plus 4x plus 4. This is actually the perfect square trinomial. It's going to be x plus 2 times x plus 2, because the 2 times 2 is 4 and 2 plus 2 is 4, the middle term. At this point, I can look for giant ones. So I see a giant 1, x minus 3, x minus 3 cancels. I see a giant 1 here, x plus 2, x plus 2. I also see x plus 2 on top and in the bottom again, so I can cancel that again. And I have x plus 3 and x plus 3. So those all cancel out. Since everything's canceled out and everything was a 1, that I canceled out, my answer is actually 1 when simplified. So the last thing I need to think about is, yes, my answer is 1, but what are my excluded values? What can x not be? Well, in this first factor, if x is -3, then I have 0, because -3 plus 3 is 0, and I cannot divide by 0, so x cannot be -3. So we're just looking at the denominators here. This factor, x minus 3, well, a positive 3 would make that 0. This factor, x plus 2, -2 would make that 0. And this factor here, same thing, because it's the same factor. So my answer is 1, where x cannot be -3, 3, or -2. Okay, let's look at the division. I don't like how this is written to start. So typically I rewrite it, x squared minus 1 over x, and then divided by x squared minus 2x plus 1, 2x squared plus x. Okay. Division is the same as multiplying by the reciprocal. So I'm going to keep the first fraction the same, change this division sign to multiplication, and flip the second fraction. That's the reciprocal. So now I have a multiplication problem set up, and I can go to that first step of factoring. X squared minus 1, that's a perfect, that's the difference of squares, so I have x minus 1 times x plus 1. The denominator cannot be factored, it's just an x. Okay, this numerator, 2x squared plus x, I have a greatest common factor of x in both of them, so I can factor the x out. And I know x times 2x gives me 2x squared, and x times 1 would give me that x in the x term at the end. And then the denominator, x minus 1 times x minus 1, -1 times -1 is the 1c term, and -1 plus -1 is -2, the b term. So if you need to draw a box and diamond for those when you're factoring, please do. I'm just practiced, and that's why my factoring is coming more easily. So I'm going to look for some giant ones. I see x minus 1, x minus 1. I also see an x on top and the bottom, so those can cancel. So I'm left with x plus 1 times 2x plus 1 over x minus 1. You can leave your answer like this. It is technically not the most simplified though. The most simplified would actually be to multiply out that numerator and get 2x squared. The middle would be 3x plus x, so 4x plus 1 over, oh, I'm sorry, I made a mistake. Go back. Let's actually use the box here because I just made a mistake. X plus 1, 2x plus 1, 2x squared, x, 2x, 1. So I have 2x squared plus 3x, there we go, plus 1, all over x minus 1. There's my answer, but x cannot be, let's look at each factor. Here, I've got an x, which means that x cannot be 0. Here, if x was 1, and here, if x was 1, the denominator would be 0. So those are my excluded values in my solution. And that's how we multiply and divide